recording with sound. I had the sound turned off, so it's even better than those recordings without sound. All right, here we go. So we've got this function, and it's got a's and b's finding the gradient of the function when x equals 2, negative 2. At first, it seems a little bit crazy because we have a bunch of things we don't know. We know that gradient means the derivative. And so if we start by taking the derivative, well, the 3 would come out in front, subtract 1 from the exponent, and we get this. Now, normally, we'd be able to figure this out by just plugging in negative 2. Because if we wanted to find the slope at negative 2, we find the derivative and then plug in that value, and we're able to solve for it. But in this case, there's a problem. The problem is there's an a and a b that we don't know. Now, one of the things that's going to come more and more natural the more times you see problems like this is when there's two things that you don't know, you're going to need more than one equation in order to figure out what those are. I think you first saw that at the end of grade 10, a little bit more in grade 11, which is called systems of equations, where if you could make, since there's two things I don't know, if I could make two equations that just had the a and the b, then I should be able to solve them either by a substitution method that you would have learned, or an elimination method that you would have learned, or maybe by graphing, but chances are this would be a non-calculator question. So there's my derivative. I'm told some extra information. I'm told that it has a slope of negative 6 at the point 1, negative 5. That actually tells me two important pieces of information. One piece of information, it tells me on the regular function, which is g of x equals 2ax cubed minus 3bx squared, that when x is 1, y is equal to negative 5. So if I plug that in and I say, into the original equation, I plug in 1 for x and negative 5 for y, do you see that I get an equation? If I simplify that, I've got one equation so far with an a and a b. If I can find a second equation with an a and a b, then I'll be able to solve for a and b. So there's my first equation. I got that because I knew the original function had the point 1, negative 5. What also do I know about the function? I know it has a slope of negative 6 at that point. So can you see that with your derivative, that when x is equal to 1, the slope is negative 6. So I can plug that in. The derivative is my slope. I know the slope is negative 6 when x is equal to 1. Simplifying that a little bit, gives me negative 6 is equal to 6a minus 6b. I'm going to call that equation 2. So my whole goal over the last little bit was to see if I wanted to figure out what a and b were, I needed two equations that had both the a and the b in it. Once I've done that, now I have to use my solving systems of equations strategies. One strategy is substitution, the other is elimination. I'll show both of them to you so that you can sort of like remember what both of them look like, and then you can pick which one you like best. So the substitution one means that you have to get one of your variables all by itself. So I'm going to take equation 2. I'm going to add 6b to both sides. And then I'm going to divide everything by 6 to get a by itself. So all of this right here was part of equation 2. The substitution method says if you can get a variable by itself in one equation, then you can substitute that into the other equation. So if I go to equation number 1 now, and equation number 1 says negative 5 equals 2a minus 3b, but instead of writing the a, since I know a is equal to b minus 1, I write b minus 1 instead. What substitution does is it takes an equation that has two things that you don't know and changes it into an equation with only one thing you don't know. Now that we have that, we can just use our algebra skills and solve for b. So we get b is equal to 3. And now that we know b is equal to 3, we can substitute that back into either equation 1 or equation 2. I'd probably plug it right back into that. That looks like the easiest thing to work with. If I plug b is equal to 3 into there, can you see that a would have to equal 2? That's your substitution technique. Your substitution technique uses the fact that you get one variable by itself and then substitute it in to the other equation so you can solve. The elimination technique says take both of your equations, line them up on top of each other. So here's my equation 1, negative 5, 2a minus 3b. And my second equation was negative 6 equals 6a minus 6b. And the idea is you can multiply both equations or just one equation, but you want to try and get the coefficients of one of the variables to be the same. Personally, I like to make them the same but the opposite sign. So what I'm going to do here is I'm going to take this equation 1, and can you see if I would multiply it by negative 2? Now I'm going to rewrite both equation 1 and equation 2. When I multiply the whole equation 1 by negative 2, instead I get 10 equals negative 4a plus 6b. And I still have negative 6 equals 6a minus 6b. So what I've succeeded in doing is getting the coefficients of b to be the same but the opposite sign. And the elimination technique said if that's the case, you can now add your two equations together. 10 plus minus 6 is 4. Negative 4 plus 6, you're left with 2a, and of course the b's then cancel out. So if 2a equals 4, then a equals 2. And once you've solved for one of them, again you can plug a equals 2 back into either equation 1 or equation 2. And you would get b is equal to 3. So on the test you get to choose. You can choose if you want to substitute or if you want to use elimination. Either are fine. Now that we've got a is 2 and b is 3, we can go back to the beginning here and say, well, I can rewrite my derivative now. Since a is 2, this would be 12x squared. And since b is, was it 3 or negative 3? b is 3, this will be minus 18x. And now if I want to find the slope when x is equal to negative 2, I'm basically trying to find g prime when x is negative 2. I can plug in negative 2. It's going to be 48 plus 36. Should be 84. So the slope at negative 2 will be 84. But we had to do extra work to begin with to figure out a and b.